Let's move on to the next chapter, chapter number 8, random variate generation. This is a part of the same module, module 3, that is random number generation and random variate generation. So first half of module 3 is completed. Here very small number of topics are less only. We have considered types of tests and only two types of almost three types of tests we have discussed about. Okay, Kolmogorov-Smirnov test, then chi-square test, as well as autocorrelation test and examples. Moving on to the next topic, that is random variate generation. So this chapter deals with the procedure for sampling from a variety of widely used continuous and discrete distribution. Okay, so both the types of distributions we are considering, continuous distribution of numbers as well as discrete distribution of the numbers. Then we are also discussing about the inverse transformation. Okay, so probability distribution function as well as cumulative distribution functions we'll be speaking about. So once again, the random number should be in the range of 0 and 1. That is what we have discussed right from the beginning. So they are the fractional values. They lies between 0 and 1. So this is what the source of the random number. It should be in the range 0 to 1, as you can see here, which I am focusing. The random numbers, let them be denoted as R1, R2, and so on. Okay, here all the techniques what we are discussing are proposed by, so Veroy, DAC, you just go through it. Okay, in it proposed by the person, name of the people, the person who has proposed the models. Okay, it is listed here, Dak Puner, Fishman, as well as Law and Kelton, in the year of you can go through 86, 88, 78, as well as 2000 respectively. So main thing you have to remember, you have to concentrate here, the random number should be in the range of 0 and 1, and R1, let them be denoted as R1, R2, and up to so on, and Rn. Okay, the PDF or probability distribution function f of r, f of r of x, or f of x of r, you can say, it should be in the range of 1 and 0. As you can see, x value will be 1, that function value will be 1 if the value, just go through it, the function value is 1 if value of x ranges between 0 and 1, otherwise it will remain 0. It cannot be considered as a random number. So your random number is the one, it will be not be having negative values and all. We are just, or we are strictly taking it in between 0 and 1. Okay, 0 and 1, then its value, the function value will remain 1, otherwise it will become 0. And cumulative distribution function, in the same way we can write the CDF formula f of r. We are using different notation. Capital F, we are using the function cumulative distribution function, capital F of x of r for the random number. You can see its values 0 as well as 1. Apart from that, we can even consider it as a value of x itself. So value of x, that is the one segment value of the random number, 0.1, 0.2, whatever, it should be in the range of 0 and 1. Otherwise, if it is less than 0, then function value will be 0, so it won't accept negative values and all. If it is greater than 1, then value of the function will be 1. So PDF and CDF, that is what the difference is. In case of PDF, uh, what is the condition? Just go through. The function value returns 0. Sorry, the value of the function returns 0 when, say, value of the function returns 0 if the range of the values are different. If it is uh, less than 0 or if it is greater than 1, in all the cases, that is value of x lies between 0 and 1, then function value will be equal to 1. Whereas in case of CDF, the cumulative distribution function, value of the function is x itself. If it lies between 0 and 1, if value of x is less than 0, that is negative value, the function value will turn out to be 0. Otherwise, it will be 1 if the value of x is greater than 1. Next is the inverse transform technique for that probability density function PDF we are considering first. Okay, let us see the discussion. Let us discuss about the inverse transformation technique in the next video. Watch the videos repeatedly, note down the things. If you have any doubt, you ask.